Okay, fine. So on our today's lesson, we are going to consider the topic acids, bases, and also salts. Okay, fine. So around us, you should know that we have the substance, and these substances they can be classified to as the acids. They can also be classified to as the bases or as another category that I'm going to mention later on. Okay. So what are these acids? What are these bases? We are going to delve into the details of trying to see what do we actually mean by these terms. Okay, so these substances they can also make us, or we can be able to identify if they can be classified to as the acids or bases by checking what we call their pH level. Okay, so what is pH? We can simply define pH as the degree or the extent of what? Of acidity or basicity or neutrality of a substance. So this means that at the end of the day, we should have three classes of substance, or we can say substance can be classified into what? Into three. So these are the classes. So they can be classified as to what? Acidic substance, or as to a basic substance, or as to neutral what? Substance. So these are the three classes that we do have, and we call that one pH. Okay, we call that one pH. Oh, so by pH. So we can take any substance and put it in what we call the solution. When it appears to be in a solution form, we can then be able to identify the behavior of the substance and see if it is either an acid or a base or a neutral substance. So that pH, the pH that I've said, have what we call a scale known as the pH scale, and the pH scale ranges from 0 to what? To 14. It ranges from 0 to 14. So from 0 to 7, these are the what? In between 0 and 7, we have what we call the acids. So there are the acids, okay? So then from what? From 8 to 13, between 7 and 14, we have what we call the what? The bases, or we can call them the alkalines. But here is the point regarding the bases and the what? And the alkalines. The alkalines are a special type of a what? Of a base. I tend to see most of the students, they tend to define pH as the degree of acidity or alkalinity. It's not like all the alkalines are the bases, but you should know that under the bases we have another another class of those bases known as the what? Known as the alkalines. Okay, but usually don't confuse yourself. You should always know that the alkalines they fall under what? Under the bases. Okay, so here at number 7 we have what we call neutral substance. So that's where we can find what we call the neutral what? The neutral substance. So these substances can be easily identified, and how do we do that? We can even use our own tongue to determine the what? The nature of a substance. If it is a base or an acid, we can know that the acids they actually what? They actually have what you call a sour taste, whilst the bases they have what you call a what? They have what you call a bitter taste. But it's not advisable in chemistry to usually taste the thing using your tongue, especially considering the lab rules. If you are not advised to do so by the teacher, you are not allowed to do such an act. Get the sense? Okay. So how do we then be able to identify if a substance is a what? Is an acid or a base or a neutral substance? We use what we call the indicators. Okay. So what are indicators? We can define them as the substance that can be used to determine an endpoint. Let me repeat this. Indicators are substances that can be used to determine the what? The end point. So when you say the end point, we are referring to determine if a substance is a what? Is an acid, or if a substance is a what? Is a base. Get the sense? Okay. So what are examples of what? Examples of the indicators that we do have. We have what we call the methyl orange. Okay, that's the first indicator. We have what we call the litmus paper, and we have what we call the phenolphthalein, and we have what we call the universal indicator. These are not all the indicators that can be used, but these are the most common ones, and I've just listed them because they constantly appear in our own syllabus. Get the sense? Okay, then I have this indicator known as the universal indicator. Okay, this one, most of the people, they tend to lack knowledge about how the universal indicator actually work in order to determine if a substance is an acid or a neutral substance or a what? A base. This is a mixture of indicators, meaning say we can combine methyl orange, we can combine it with what? With the phenolphthalein, we can combine with quite a lot of the indicators and form what we call a universal indicator. I'm going to use the concept of the universal indicator here to demonstrate how do we know if a substance is an acid, neutral substance, or a base. I've already raised a point and said that the acids, they have what we call low pH, meaning say it's the pH of what of the acids ranges from 1 to what to 6. Okay, then 7 here shows the neutral substance, although it represents those substances that are said to be neutral. Then from here we have what 8 to 13, these are the bases. But here's the point. So we have said that above 7, which is high pH. Okay, so all the bases, they have high pH. Then all the acids, they have low pH. That is below 6. Get the sense? Okay, below 7, I can say that. Okay, then 7 represents neutral what? Neutral substance. Here is another point that you should know. Of course, all the acids, they can be said to be the acids. Okay, or we can classify them as two acids. But they do differ in terms of what? The degree of acidity. Let me just pinpoint again the point that I've already raised. I've said that by pH, we are saying the degree. It can be an acid, but how acidic is that substance? Okay, it can also be what? A base, but how basic is that substance? Get the sense? So we have to check to see the degree of what? Of acidity. I'm going to later on demonstrate or show you the properties of what of each and every substance that we can also encounter as far as the acids, the neutral as well as the bases are concerned. Okay, so this also gives us another class of what? Of acids under the acids, of bases under the bases. So we have the acids that are said to be strong acids. We also have the acids that are said to be weak acids. So I've used the color red for to represent the strong acids. Okay, so 1 and 2 represent strong what? Acids. So those strong acids, they have very low pH. Okay, then those that have a pH which ranges from 3 to 6, these are weak what? These are weak acids. Or I can say those that are close to 7 or that are close to neutral, they what? They represent some weak acids. And then if we go to this other side where we have high pH, these are the bases, isn't it? Then the range is from 8 to 13. Then close to neutral again, these are the weak bases. So 8, 9, 10, and 11, they are considered to be weak what? Bases, whilst the 12 and what? And the 13 represents somewhat some strong bases. So we have weak bases, we also have what? Strong bases. Someone might also need to know what are the difference between the substance, between the acids that are said to be strong, and what are the difference between the bases that are said to be strong and those that are said to be weak. The difference is clear. It's all about their behavior when we add to water. Okay, so I've said that the acids, they can produce what we call the hydrogen ions when dissolved in what? In water. Meaning to say, if you take an acidic substance and place it in water or pour it in water, it can what? It can partialize, or we can say it can ionize, or it can produce this what? A hydrogen ion. So this is the behavior of the acids. The acids, they actually produce what we call the hydrogen ions. So all acids, they produce the hydrogen ions. So here now come the question, okay? What's the difference then between what? Between strong acids and weak acids. So it's all about how they ionize. The weak acids, they partially ionize, or they partially what? Dissociate, whilst the strong acids, they completely dissociate, or we can simply, they completely what? Ionize, more like that. So that's the main difference between the strong and the weak. Same applies as of the bases. The bases, they do produce different what? Ions. As compared to what? To the acids. These ones I've said that they produce the hydrogen ions, whilst the bases, they produce what we call the hydroxyl ions, or some they call these ones the hydroxide ions. So hydroxide ions are produced when you add a what? A base in what? In water, or when you dissolve a base in water. So it produces these ions known as the what? Known as the hydroxide, which is OH negative. Then also here is what? The hydrogen ions, which is H to the power positive, more like that. So that's the main difference. Then the neutral substance here, they have a what? They have a pH of 7. Then let us look at this indicator that I have already highlighted, the universal indicator. So the universal indicator makes it even as easy for us to identify if a substance is a strong or a weak base, or a strong or a weak what? Acid, more like that. Get the sense? So all acids in a what? When we add an indicator, this one, in a strong acid, it will turn into a what? a red color. So a red color will represent in an universal indicator or a mixture of indicators. You end up having that red color, which represents the what? The hydrogen ions that are actually present in the substance. And I've said that they are actually or generally what? They are generally more, or we can say they simply ionize as compared to some weak what? Some weak acid. Then here the color is what? So I've said red here for strong acids. Then here for weak acids, it's usually orange or yellow. So orange, that's 3 and 4. Then as we are approaching or moving close to 7, it turns to a what? To a yellow color. So that's for what? For the acid. Then as we move on to this other side, here, the strong bases, they have a color which is often known as the purple, or we can say lilac, more like that. Get the sense? Then as we go down here or moving close to neutral, we experience what? A blue, dark blue color. Then here we end up having what? A light blue color, more like that. In the sense, so it definitely means that these colors that I have shown, I've said that is red, which represents what? Strong acid. Then I've said orange and yellow, that's what? For weak acids. Then green, that's for neutral. In a what? In a universal indicator. Then also we have what? Light what? Light blue and dark blue, or some they say it, they call it navy blue. Then here we have purple. So light blue and what? And navy blue represents weak bases, whilst purple represents what? The strong bases. So that's what you should know regarding the what? The colors of what? The colors of acids and bases in what? In an indicator which is known as what? The universal indicator. Then here, let us look at the properties. The properties are the what? Are the features that allows us to be able to identify if a substance is an acid or a what? A base. Okay. So here are the properties. The first one, I've already said that the acids, they actually produce the hydrogen ions when dissolved in what? In water. Then the what? The acids, they turn this litmus paper, which appears to be in 2 colors, either blue or what? Or red. So it turns a blue litmus paper, it turns to a red color in a what? In an acidic solution. Okay. Then the acids, they also have what we call a sour taste. Okay. They have a sour taste. They can also react with the bases. That's another property. Can react with the bases to produce what? Or to form salt and water. Salt and water, they are classified to as what? They are classified to as neutral substance. Get the sense? Okay? They are classified to as neutral substance. So we can say the products of an acid and base reaction produces the what? The neutral substance. More like that. Get the sense? Then also the general property, which appears to be on both the acids and the base, is that they are all corrosive. Meaning to say, they can erode the surface, more like that. Get the sense? Then as of the bases, I've said that they produce the hydrogen ions, or the hydroxide ions, or we can say the hydroxyl ions, when added or when dissolved in what? In water. Also, I've said that it also turns what? This litmus paper, which appears to be red to a what? To a blue color. So it changes red to blue. Then they have a bitter taste. Unlike the acids that do have what we call a sour taste. Then also they can react with acids to produce salt and what? And water. And I've already said that salt and water are what? Are said to be neutral what? Neutral substance. Then they are also corrosive, just like what? Just like the acids. Then here are some good examples of bases as well as the acids that we do have. We have the first one, sulfuric acid. The acids are easy to identify. Okay? Why? Because they always end with the word acid. So we have sulfuric acid, we have phosphoric acid, nitric acid, carbonic acid, ethanoic acid, hydrochloric acid. They are all acids because they end up with this one. Propanoic acid, you can have as many as possible what? As many as possible these of these acids. Then as of the bases, we actually have calcium. There's a trick regarding how these bases are actually named. Okay, most of them, some of them they end up with oxide, some of them they end up with hydroxide. As you can see, we have sodium hydroxide, we have also calcium hydroxide, and we also have calcium oxide and magnesium oxide. So we have what we call the metal oxides that are said to be the what? The bases, and we also have what we call the metal hydroxide that are said to be the bases. But the bottom line is that all the bases, they behave in the same way, meaning say they produce the hydroxide ions when dissolved in what? In water. Okay. Let me just take you back regarding what actually what we actually encounter on our day-to-day lives. So we have this substance that we use at home. that we can simply classify to as the acids, and those that we can also simply classify as to what? As the bases. Just for instance, let us start with the acids. You should know that in milk we also have an acid, but it's a weak what? It's a weak acid, which is it's close to 6. Get the sense? Then also we have what? Oranges and lemons. They are said to be citrus, isn't it? Citrus fruits, and they have this citric acid, an acid known as what? Citric. Also the what? The grapes. The grapes are also what? Are also classified to the group of what? Of substance that are said to be acidic. Get the sense? Okay. Not only that, if we move on to the bases, substances like toothpaste. Toothpaste is a base. Okay. What else? We can also consider another substance like what? Like soap and some detergents and some disinfectants that are usually used in what? In toilets. They are also classified to as what? As the bases. So these are the products that we actually use or we commonly use at home that can be classified as to acids or what? As to bases. Okay. Then let us move on to what we call neutralization. Okay. Or I can say that's how we can end up forming what we call a salt. So by neutralization, remember these colors represent a certain thing. Here I've said that red is for what? For the acids, green for neutral substance, and blue for what? For the bases. You get the sense? Considering the what? The universal indicator. Okay. So if we combine an acid and a base, remember I've said that they can react, the acids can react with the bases to produce salt and water. And same applies, the bases can also react with acids to produce salt and what? And water. So always salt and water will be produced if in a what? In an acid-base reaction. An acid-base reaction is known as neutralization reaction. Okay. So we are combining what? We are combining the hydrogen ions and what? The hydroxide ions. So if we add H and H, we form H2. Then we have O. So that O forms what? H2O. H2O is what? Is a salt. Okay? So H2O is a salt. Then the other parts of what? Be it let me just consider the first one. We have sulfuric acid and what? And calcium oxide. Okay? So we have the O here. We also have the H here. Then the H here is H2. I think we all know that, isn't it? So we have H2 for sulfuric acid. Sulfuric acid, the chemical formula is H2SO4, okay? Then we also have another O here. We'll combine the H2, the OH in what? In the bases and what? And the H in what? In acid, and we form what we call water. So that's water. Then the remaining part is the sulfate, okay? Of sulfuric acid and also the calcium. So they form a salt. So the salt will be what? Will be calcium sulfate. Sulfuric acid always produce the salts that are said to be or known as the sulfates. Same applies. Nitric acid always produce the salts that are called what? The nitrates. What? Carbonic acid produce the what? The carbonates. Get the sense? So that's the idea regarding the what? The salts that will be formed. So they are all based on, just like hydrochloric acid always produce what? Always produce the what? The chlorides, more like that. Okay. So let me try to match these ones and find some of the salts that we can form considering an acid-base reaction, and also the salt. As of water, we always get water. So there is no name of a water that we can find in an acid-base reaction. But as of the salt, we should have a specific name of a salt. Like what? The salt that we actually use at home, which is also known as common salt. Some they call it table salt, some they call it household salt, which is sodium chloride, NaCl. Get the sense? Okay. So let us try to form that salt. So we can use what? Sulfuric acid and what else can we use? Remember, it's sodium. So we can use sodium something. Okay. Sodium hydroxide here. Okay. So it's sodium hydroxide. Sodium hydroxide. Then we add it to what? Sorry, this is a what? This is supposed to be a base. So that's sodium hydroxide. Sodium hydroxide. Sodium hydroxide. That's a base, isn't it? Okay, then in acid, I'm going to use sulfuric acid. Sulfuric acid. Okay, so if we combine the two, what we are going to get will be a salt. But a salt is determined, its name will be determined by the what? The acid, which will be the sulfate. So if we combine a what? If you combine sodium, we take this part. The hydroxide party will form water with another H in what? In this acid. So we take this sodium, then the sulfate. So the salt that will be formed will be what? Sodium what? Sodium sulfate. Okay? Sodium sulfate. Then water. Water is always water. So we form water, which is what? water is water, just like that. Okay, so this is a what? It's a neutralization reaction because we have combined sulfuric acid and what? And sulfuric acid, which is an acid, and sodium hydroxide, which is a what? A base to form sodium sulfate and what? And water, just like that. Get the sense? Okay, then we can also write this one using what you call the what? The chemical symbol. So sulfuric acid is H2SO4, just like that. Then we say plus sodium hydroxide. We usually call it what? That's Na or what? OH. Okay. Then we form what? This one, sodium sulfate. That's Na what? Na2 S or what? SO4 plus what? Plus H2O, just like that. Okay, fine. Then you have to check. We do what we call balancing of what? Of equation. So how to balance the equation? We have to check the number of what? Of elements appearing on both the sides. Let us check first of all. Hydrogen, how many do we have? We have 3, isn't it? Okay, we have 3 of them. So we have 2 here, we have 1 here, then here we only have 2. Then oxygen, we have 5 this side, we also have 5 this other side, isn't it? Then what else? As of what? Sodium, we have 1, also have what? We have 2. So we have to put a 2 here. Okay, what does that mean? We now have 2 sodium atoms now balanced with this one. Get the sense? Okay, but as of what? The oxygen, what does that mean? We can now have, what do we have? We have 4 oxygen here. Now we have 6, isn't it? So we can also put another 2 here. So that's H2O. We can put another 2 here. So we end up having what? 4 hydrogen. Okay, then 4 hydrogen. They need 6 oxygen, 6 oxygen. So the equation is now balanced just like that. Okay, so in short, this is how we can actually what? We can actually form some salts considering what we call the neutralization reaction. But that's not all. Sometimes we can also use only a what? An acid and a metal without a base. We can also be able to form a what? A salt. But the other substance will not be water. Rather, it will be a what? A gas known as hydrogen, more like that. So that is that. That's what I wanted to share with you today regarding this topic of acids, bases, and salts. I'm Putin, and for now I'm signing out. So I say, peace be unto you.